Hello class, this is Mrs. Zappia with Eureka Math Lesson 10, Interpreting Graphs of Proportional Relationships. The essential question is, what 2 points will always appear on the line representing 2 quantities that are proportional to each other? Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. Use this information to complete the chart. Create a table comparing the amount of flour used to the amount of cookies. So we need to fill in our table with our variables. Remember that the X quantity is always the column on the left and the Y is the column on the right. The amount of cookies depends on how much flour you have. So cookies is dependent, which is the Y variable. And the recipe said that if we have 4 dozen cookies, that required 3 cups of flour. Now, create a table comparing the amounts. So let's say that we are going to double the recipe. How much flour would we need and how many cookies would that yield? If you double the amount of flour, you will need 6 cups. If you double the flour, you double the amount of cookies you make, which will be 8 dozen. You could also triple the recipe. So that would be 3 times as much. So 3 times 3 and 3 times 4. Because if you triple the amount of flour, you triple the amount of cookies you make. And finally, let's make 4 recipes. So you'll need 4 times as much flour, and 4 times 3 is 12. And if you use 4 times as much flour, you will get 4 times as many cookies, and 4 times 4 is 16. Is the number of cookies proportional to the amount of flour? Explain why or why not. So what we want to do is determine the unit rate for each ordered pair to tell if they're proportional or not. To determine the unit rate, remember to divide y by x. Y divided by x. So we do that with our first pair, 4 divided by 3, and that gives us 1.3 repeating. And then 8 divided by 6 is 1.3 repeating. 12 divided by 9 is 1.3 repeating. And 16 divided by 12 is 1.3 repeating. So the number of cookies is proportional to the amount of flour used because there is a constant of proportionality, 1.3. In the next question, what is the unit rate of cookies to flour? And what is the meaning in the context of this problem? So let's write down y over x. And remember that y represents the dozens of cookies. And c represents, or x, represents the cups of flour. So when you're calculating the unit rate, you are calculating how many cookies it will take or how many cookies you will get from 1 cup of flour. So remember that the unit rate is when you have 1 in the denominator. So that will represent the number of cookies for 1 cup of flour. Well, the unit rate we calculated over here, and it is 1.3 repeating. So 1.3 repeating. Now on a measuring cup, you don't have 0.3 repeating. So let's convert that to a fraction. 1.3 repeating is equivalent to 1 1/3. So we'll use the unit rate of 1 1/3. And what it means in the context of this problem, 1 1/3 cup of flour yields 1 dozen. Whoops, I wrote that backwards. I'm going to go back and fix that. I'll just get rid of that. Let's erase that. Again, the unit rate, you want to pay attention to what you want 1 of. And I almost messed up there. So it means you'll get 1 1/3 dozen cookies. When you use 1 cup of flour. Next, model the relationship on the graph. So we're going to model the data from the table, and we'll need to fill in our numbers on our graph. So we want to label our X and Y axis. Do you remember which is which? The X-axis is the horizontal axis and the Y-axis is the vertical axis. Then we'll need numbers along the axis and a label. So the numbers on the X-axis, remember that X represents the cups of flour and Y represents the dozens of cookies. So now let's go ahead and graph our data. We have 3 cups of flour representing 3 cups of flour makes 4 dozen cookies. Then 6 cups of flour represents or makes 8 dozen cookies. And our next ordered pair, 9 cups of flour, and that will make 12 dozen cookies. And this one does not fit on the graph, so I'm just going to leave it off. Then I'm going to go ahead and connect my data dots. And the next question says, does the graph show the 2 quantities being proportional to each other? Explain. So I want to know, is it a straight line and does it pass through 0? Well, so far it is a straight line. I need to extend it to see if it will pass through the origin 0. So let's pull that through the origin, and yes, it is a straight line. It passes through the data points and the origin. So it's a straight line, it passes through the origin, and that means that the quantities are proportional. Next, write an equation that can be used to represent the situation. So we're going to start with the structure of the equation. We've already calculated the unit rate. So the structure of the proportional equation is y equals kx. Then we're going to replace k with the unit rate, which is 1 1/3. So y equals 1 1/3 x. And the last thing that we're going to do here is we're going to replace x and y with D for dozen and C for cups. We're going to replace X and Y with dozen and cups. So we have to know which is which. So we look at our table again to review, and X is the amount of flour. So we were using cups for that. So we're going to replace X with cups, bring down the 1 1/3, and for Y, that represents the dozens of cookies. So this is the equation for the proportional relationship. This is the same equation, but it's a little more specific because it tells you which variable is the dozens of cookies and which variable is the number of cups of flour that you will use. This is example 2. Below is a graph modeling the amount of sugar required to make Grandma's chocolate chip cookies. So the previous question was about flour, and this question is about sugar. And it says, record the coordinates from the graph and what do the ordered pairs represent? So I'll get you started here. The first point down here at the bottom is 0, 0. And the second point is 2, 3. And I'd like you to pause the video and fill in the rest of the data points. So what do the ordered pairs represent? The X represents the cups of sugar and the Y represents the dozens of cookies. Next, Grandma has 1 cup of sugar. How many dozens of cookies will she be able to make? And plot the point on the graph above. So if you want to know the amount for 1 cup of sugar, what I want you to do is extend the table with another row and then add 1 cup of sugar. So we'll extend our data table. Now, which column does the 1 go in? Correct, it goes in the cups of sugar. And then you need to figure out how many cookies she can make. In order to do that, you're actually calculating the unit rate because you want to know how many dozen for 1 cup of sugar, and that is by definition the unit rate. So you take any ordered pair to calculate that. To find the number of dozen of cookies, would you multiply or divide? So you're going to take an ordered pair. Let's use 4 and 6. Well, let's see. Find the answer and write the ordered pair. So it doesn't matter which ordered pair you use. Again, let's use 4 and 6. And when you're calculating the unit rate, remember to divide y by x. So 6 divided by 4. And calculate that answer. And the answer is 1.5. So we calculated the unit rate, which is 1.5. And now it says to graph that amount. So we'll go up and graph the ordered pair 1, 1.5. So the ordered pair, we go over to 1 and then up 1.5, and it will be right there. So I want you to notice that the unit rate is on the line that shows the proportional relationship. That's the unit rate, 1 and 1.5. Also, 0, 0 is on that line that shows the proportional relationship. What is the unit rate for this proportional relationship? Well, for any pair, we actually already calculated this. It's y divided by x, and it's 1.5. So that means that you can make 1.5 dozen cookies with 1 cup of sugar. Next, how many dozen cookies can Grandma make if she has no sugar? No sugar, no cookies. Can you graph this on the coordinate plane? Well, you need an ordered pair, so what would the ordered pair be for no sugar, no cookies? It would be 0, 0. So it is graphable. And what do we call this point? This is called the origin. So we already graphed it. We already have 0, 0. So that's one point that's on the line that shows the proportional relationship. Let's do that in red. 0, 0, that's on the line that shows the proportional relationship. And then another line, or another point, that will always be on the line that shows a proportional relationship is the unit rate. So the unit rate and the origin will always be on the line that shows the proportional relationship. And the next thing, think about this. What 2 ordered pairs must be on every line that shows a proportional relationship? All right, so they are 0, 0 and 1R, where R is the unit rate. So again, the origin will be on any line that shows a proportional relationship, and the unit rate will also be on the line that shows the proportional relationship. So again, here, let's do this in green. This is the origin, and this is the unit rate. And both of those points will be on any line that shows a proportional relationship. All right, so we're on exercise 1, page 40, lesson 10. And it says, the graph below shows the amount of time a person can shower with a certain amount of water. And we have gallons going across the x-axis and minutes across the y-axis. And it says, can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons of water? And explain how you know. So you can determine proportionality from the graph. And the line is straight and passes through the origin, so the relationship is proportional. How long can a person shower with 15 gallons of water? How long can a person shower with 60 gallons of water? So let's take a look at the graph and find 15 gallons of water. So we have 5, 10, 15. That's the number of gallons. Then you follow it up where it meets the line of proportionality. Then you follow that over to see how many minutes it is. So we read the graph to answer the questions. 15 gallons, you'll get a 5-minute shower. Now for the next one, how long can a person shower with 60 gallons of water? So I want you to pause the video and find that out, and then check the answer. So the answer is, with 60 gallons of water, you can take a shower for 20 minutes. What are the coordinates of point A, and describe point A in the context of this problem? So looking back at your graph, we have point A, and point A is 30, 10. All right, so point A. So here's 20, 25, 30, and then following it over to 10. So this is the point 30, 10. Describe point A in the context of this problem. So what does the 30 mean, and what does the 10 mean? The 30 means 30 gallons, and that will give you a 10-minute shower. Can you use the graph to identify the unit rate? So let's take a look at the graph, and remember the unit rate is where the x value is 1. So if this is 20, then this is 5, 10, 15. So we have to estimate where 1 would be. 1 would be about here, and then you need to see where it intersects that line of proportionality, and then read what number it is on the y-axis. So while you can identify it, it's hard to say specifically what it is on this graph. So the unit rate, which is 1R, the ordered pair 1R, isn't obvious. So using this graph is not a good way to determine the unit rate on this graph. Plot the unit rate on the graph is the point on the line of the relationship. So let's calculate the unit rate. With the ordered pair 30, 10. 10 divided by 30 is 1/3. If you use a calculator, 0.3 repeating. So that is the unit rate, is the point on the line of the relationship. So let's write the ordered pair for the unit rate. And that means for 1 gallon, you get 1/3 of a minute of shower. And let's graph that point. So we have 1 and then 1/3. And yes, it's on there. So this is 4, 3, 2, 1. And then 1/3 is about there. All right, so is the point on the line of the relationship? And the answer is yes. So the unit rate is a point on the line. It is a point on the line. The unit rate will always be a point on the line if it is a proportional relationship. Next, write an equation to represent this relationship between the number of gallons used. So you want to find the unit rate, which we did, and it is 1/3. Then you want to plot that point, which we did, and it is on the line of the relationship. And next, writing the equation. So writing the equation, remember your first step is to find k, and we know that k is 1/3. The second step is to write the structure of the equation, y equals kx. And the third step is to replace one of those variables with the unit rate. And you replace k with the unit rate. You can also use the decimal 0.3 repeating if you prefer. So that's the equation that represents the gallons of water used and the length of the shower. If you wanted to replace the variables, look at the table or look at the graph, and remember that the x is the gallons. So that would be 0.3 repeating, G for gallons is equal to M for minutes in the shower. And either one of those equations would be correct. Please pause the video and try this problem on your own. Press play after each question before continuing. This will give you a good idea of how well you understand the lesson, and we'll go over the answers at the beginning of class tomorrow. So I changed my mind about putting the answer here as you go along. I'd like you to complete this whole page, and we will correct it tomorrow in class. So that's a wrap for lesson 10. Please complete this page and bring it to class tomorrow.